once the room starts filling up, which they're starting to come in now. So
We just went live.
oh well then. Thanks, Doug. All right, for those on the remote feed, I'll just reiterate the same message. We'll be starting in a few minutes. So if you would get situated, join the IRC channel. That's OCP-networking on the Freenode server. We'll be taking questions throughout the entire session. Make sure everyone's able to participate, and we'll go from there. So make sure you get something to drink, something to eat. It's going to be very exciting times.
Okay. Someone even around there. Yeah, I spent a lot of money for those. $4? Yeah, they weren't that cheap. I think they're probably. Yeah, well, that's a good surprise. Yeah, it does look great. Yeah. Did you play Magic? Someone in the morning? Oh, he was not here. Yeah, he was stuck in the train. Yeah, they were. This morning, we were Turkish. That's
Cool. So I guess while we're doing it, anyone on the IRC channel in the room? You are? If you're on the remote feed, can you hear me?
Audio's good.
Not going to risk that, but
Fantastic.
it could be the same thing.
Is anything whitewashed? Can they see everything?
In this view, it's whitewashed. They should be able to see the screens in this view.
So right now it slides.
No, I mean as long as they can make out everything, they can hear. We're doing better. Cool. So we give a couple more minutes, Omar. We'll kick it off, and then out we go.
I think that was it. Options.
All right, let's go ahead and get started. So, welcome everybody. This is the go out here. This is the networking track. I'm Omar. It's Carlos, and so we've got a bunch of stuff here today lined up. Just logistically, again, if you're a presenter, please make sure you send us your slides so we can post this up on the wiki. Those of you who are in remote land, you can ask questions on the IRC channel, and we can get those asked to presenters. We've got, I think I recognize a bunch of the faces you were here this morning as we gave this overview of the networking project. So we've got a whole bunch of stuff this afternoon, ranging from, again, the hardware to the software to the testing, validation, integration, and profitability. So should be something for everybody in the room, right? So we'll kick it off with Jeff Catlin from Acton to talk about their submissions to date and some new submissions. Thanks. Help me welcome Jeff.
Thank you. Okay, well, thank you all for coming. Thank everybody remotely for tuning in. My name is Jeff Catlin from Acton Technology Corporation, and we're going to go over a little bit about some previous submissions, contributions that we've done to OCP, and also a couple of new contributions which we're contributing as of today. So just an overview of who Acton is for those of you who may not be familiar with Acton. We're a networking ODM with headquarters in Taiwan. Been around for 25 years, and we specialize in making networking products. We're publicly traded on the Taiwanese Stock Exchange. We have 3,000 plus employees. Acton is the parent company of EdgeCore Networks, so you may see and hear reference to EdgeCore Networks. That is the brand that Acton uses to supply products through channels. Okay, so that's a wholly owned subsidiary of Acton, is EdgeCore Networks. Acton is the owner of their own high-volume manufacturing. We have facilities in China and also Taiwan. And Acton has been a very active member in OCP for about the last year and a half now. So start off with the more simpler contributions that we've done to date. So the first one is a rack adapter. So the rack adapter was submitted back in May of 2014. I believe it will be accepted by the incubation committee as of tomorrow. So it looks like we have enough votes to get through this time. There were some changes that were requested when we went back and they changed the rack adapter. So that stuff's all done. Basically what the rack adapter is, it's a mechanical sled that allows any 19-inch rack mountable 1RU switch or any other component to be installed in an open rack. The equipment slides into the rack adapter just like it was a 19-inch rack and mounts to the rack adapter just like the rails of the 19-inch rack itself. On the rear end of the rack adapter is a standard method connector that plugs into the center power bus bar of the open. So just some things we were aware of as we went through the designing of the rack adapter, although it seems simplistic. One of the first things was the method connector we used only provided horizontal flow, and it was brought up that we need to find a way to mount that where we have vertical flow. That's important. So when you pre-install your equipment in an open rack and you ship it and it vibrates as it's shipped, you don't wear down the power bus bar. So that's one thing we took into account when we designed how the connector mounts in there. It's got horizontal as well as vertical flow. We came up with latching mechanisms, so you slide this in and it latches right to the side of the open rack. And one of the last suggestions was that we have some cable routing holes front of that adapter. So in case there's a switch or some kind of component that you use the adapter for, it has some kind of ports on the rear of the unit, you may need a way to get cables through that rack adapter into the tray. So we put a couple holes on each side with some grommets around it, and those are some of the design points we went into the rack adapter. So as far as switches, we submitted a switch back in May at UTSA, the meeting back there, 2014. It was a Trident 2 switch, 48+6 Trident 2-base switch. It was accepted by the incubation committee in October of 2014, and it was the first switch that's been accepted by review. We're pretty proud of that. It's a pilot design based on Broadcom Trident 2. And it offers flexibility in the mechanical packaging, power options, airflow, CPU selection. A couple of pictures of the unit here. The mechanical packaging, of course, will fit in a 19-inch standard rack with the rack adapter. Okay, this can be plugged into an open rack and draw power right off the open rack full power system. Power supplies, we support standard AC, standard 48-volt DC, and also 12-volt power module from the open rack. Airflow options, back to front, front to back, standard stuff. As far as CPU modules, there's 2 CPU modules. It's a modular CPU in this, and we submitted 2 designs for this switch. One was an Intel x86 Rangeley-based CPU module. There's an optional MSATA storage on it. And the second module is a Freescale B2041, which has optional SD card storage. Some pictures here, pretty straightforward stuff. The top it shows, the big Broadcom Trident 2 chip. There's 3 CPLDs on board for SFPs and housekeeping type chores. There's a Broadcom PHY on the motherboard, and a modular CPU. It's basically the switching itself. It's very designed to be cost optimized and highly reliable. On the front panel, you have your 38 SFP plus ports. There's 6 SFP ports. The rear, we have 4+1, so 5 total power fan modules, so we can run with only 4. So it's fully redundant. Dual power supplies that are redundant. All the options on the back are color coded. So this picture here shows orange handles on the back, which means the hot air is blowing from front to the back. There are blue handles on the back that indicate that the air is getting sucked through the unit from the rear to the front. Okay, so those were the 2 original contributions we made last year. So the rack adapter, switch with the 2 CPU modules, actually makes 2 different SKUs from the switch to 2 switches on rack adapter. And that brings us up to today. So we are doing 2 more submissions today. The first one is a 32 by 40 gig switch. Again, this is based off Broadcom Trident 2. It's much like the 5712, the previous switch, where it's a PHY-less design, so designed to be low power, low latency, high reliability. It is a companion product to the 5712, so it takes the same power supplies, same fan foods, the same CPU modules. So for end users that buy these switches, the throughs are interchangeable between the 2. Again, this has all the same characteristics of 5712 as far as mechanical packaging for open rack, a 19-inch rack, the power options, and again, the same CPU. So this is a submission that we are a contribution as of today. The specs should be online, I believe, on the wiki by now. So you guys can go out and review the specs for this as of today, and I believe this presentation is available also. So that's the first contribution today. Block diagram of this design is pretty straightforward. Again, it's got the Trident 2 there. And it's PHY-less, so the SerDes route right out to the front panel. Connections, you see the PHY on the board. It's a 100-pin board-to-board connector for the CPU module, so it's PCIe times 2, going from the CPU module to the Trident 2 chip, and the standard UART and Ethernet ports going down for that connector as well. So pretty straightforward, clean design. the second contribution is a 32 by QSFP 28 switch. So today we are contributing a 100 gig switch. So this is 32 ports of 100 gig, and if you're familiar with the Tomahawk chip from Broadcom, the ports can run in any one of many modes. They can be 10 gig ports on the 128 10 gig ports on the front of this through breakout cables. There can be 64 50 gig ports. There can be 32 40 gig ports. There can be 3200 gig ports. So very flexible. The SerDes on the chip can run at either 10 gig or 25 gig. It's a very flexible design for either top of rack installations or for spine installations. And if you follow through, the slides read kind of the same, because we have the same methodology as we design products. As far as mechanical packaging and modular CPUs. So again, this one goes into the open rack with a rack adapter and a 12-volt power module that we can supply. Airflow options, it's back to front, front to back, same as the other two. Again, this is a modular CPU design. CPUs have been kicked up a little bit in our newer designs going forward, where we still offer a Freescale design. This one is a Freescale T2080 CPU design for this. And the Intel x86 design is a Broadwell DE, or I think it's Xeon D, they call it now, class processor. So again, modular CPUs, all the same color coding components as we had on the other product. So again, this spec is available online also today for the 32 by 100 gig switch. Looks fairly similar to the other two switches. Pileless, very clean on the front, right from the SerDes, right from front panel connectors. A little bit of a difference here. There's 120 pins on the board-to-board connector. That's due to some new functionality in the Tomahawk chip. So on this design, we have PCIe Gen 2 times 4 lanes going between the processors and the Tomahawk chip. There's also two 10 gigabit ports coming from the Tomahawk chip that are routed right into the processor complex for additional packet delivery up to the CPU system. On here also, you'll notice between the Tomahawk chip and the board-to-board connector, there's an FPGA there. That FPGA is connected to the automated stats interface on the Tomahawk chip. So there's an FPGA connected to the automated stats interface, and then to the other side of that FPGA is PCIe lanes and also I2C control as well. This shows the Freescale module on this block diagram. There's also in the spec of the block diagram for the x86 CPU module as well. Okay, so very similar design to the other ones, although it's very much more functional as far as the front panel ports from 100 gig. Like I said, 25, 50, 40, 10 gig, around any one of those speeds. So very flexible. And it's got the enhanced management capabilities of the 10 gig ports to the CPUs and also the automated stats. So very interesting design, very flexible, a lot of functionality that can still be exposed on this design through some unique software functions going forward. So a very exciting design for this. So the submission package today, we submitted the specifications. Assuming we're still going through the standard process where the specifications will be reviewed by the community, and we'll get on a call and go over any questions or concerns with the specifications. Once that's cleared up and we actually get to the point of submitting the material for the specifications, our standard specification submittal before, as far as the design container, was the paper product spec, the schematics in PDF format, all Gerber files for all PCBs, full mechanical package, step 2D files, tolerance dimensions, all that stuff is submitted. Bill of materials is submitted with vendor names and part numbers, all the assembly drawings, binary images for CPLDs and FPGAs, and test pieces, which I'm assuming is going to be required. So this is what the design package looks like when we do our final submission after we go through the review of the specification. And all our contributions have support for the following OCP portion. So all of our switches that we submit support O&L, and we make O&L available on our website for free download. So customers can go out and download the binary O&L image and install it on the switches themselves. They can go out, I'm sure, to the O&L GitHub and build it if they so choose. That's what they want. We support only on all of our switches. Today we have 4 switches that pass certifications, 6 total supported today, SKUs. With this 2 submissions times 4 SKUs in the CPU, this will bring us up to 10 switches that support ONI. So very large number of switches that support ONI supplied today. Our submissions support APD, and there'll be some talks about what APD is going forward here in the next few minutes. It's more simpler things that we support, but it's still a requirement for OCP and very important to customers. Simple things like the luggage tags. So all our designs that we submit have what's called what we call a luggage tag, and it's basically a pull-out piece of plastic with a model number, serial number, and MAC address stored. So when you rack 32 of these for a spine, let's say, and you have to do inventory, right? You can just pull out this little piece of plastic like Service, have it scan it, and that's how your text. We also support, as part of the documentation package that we submit, is a quick start, a generic quick start guide, which has references to simple ONI and how you get ONI started and downloaded, and other things about the console port pinout and all the other things that are part of the ONI certification test plan. Okay. So with that, that's all I had today. So those are the 2 submissions that we're doing today, the 32 by 40. And I think more exciting is a 32 by 100 gig switch. So I've been doing this for, I hate to say it, 25 plus years now. And just the thought of a 32 400 gig switch is overwhelming. It just blows my mind that there's those today. Even more so, it blows my mind that there's vendors submitting open source hardware packages for 32 400 gig switch today. So very interesting and very exciting now. And if we have time for Q&A, we'll do some of that.
Time for a few questions.
If I can't answer them, there's smarter people here. Much smarter. The switches are right here, and the rack adapters here. So everything we're submitting is up here on the table for viewing throughout this. But we also have a table in the hall, the expo hall. We are not doing a working demo. There's another company doing a working demo on some software that's coming up here this afternoon session on one of these switches, on one of the submissions.
So about the CPLD and the FPGA, I saw you only provided the binary. Will you provide the source code also for the CPLD?
We have it today. We support the binary image so people can reproduce the design.
Jeff, can you talk about the physical interface you mentioned on the 100 gig? Was it a BMC or was it
no, the Tomahawk. Yeah, the question was about the statistical interface on the block diagram that I showed for the 100 gig switch. So I can tell you what I know, which is going to be quick. The Tomahawk has what's called an out-of-band stats interface. It's a serial interface that transmits constantly information about the buffer utilization statistics of the switch chip. And so there's these ways you can put components there to capture that data, and then the CPU can go in and retrieve that data, or the FPGA can push that data to memory, however you want to implement that. But we put that FPGA there, so that functionality could be supported by NOS vendors, by other people that want to write applications that ride on top of or with NOS vendors, however somebody wants to dispose.
Just one comment also in terms of the specifications. So they will all be available by either tonight or tomorrow morning. We'll try to get them also up. There are a number of different companies with specifications. They are coming out at different times, and so I just want to kind of Acton's the first to sort of to present and go. So if they're not there, within the next couple of hours, they should be definitely there by tomorrow. Thanks.
Is any performance test result also published?
We have performance test data. We do not publish that. So there's packet throughput tests we do, there's IEEE conformance, and all kinds of testing we do to validate our designs, but we don't normally publish that data. Now, one of the things we need to work through as a group is there was a vote on getting test plans as part of the submission. So we need to figure out what that means. The manufacturing test plan, the performance test plan, what is that, what kind of data are we going to submit for that? But today, we don't publish that information, although we do discuss that.
Anything else? All right.
Very good. Thank you.
Thanks much. All right, so we've got next up we've got an ONI testing, or an ONI update and a testing status.
That's right. Is this thing working?
Live.
All right. Thank you, Matt. My name is Kurt Brody, and I'm with Cumulus Networks. And I'm here today to talk to you about ONI, the Open Network Install Environment. It's something that Cumulus and Big Switch contributed to OCP about 2 years ago. I think we demonstrated it in May. And so it helps NOS vendors to be able to install their operating systems on any given white box platform. So we really wanted to blow open the ecosystem for white boxes and help everyone compete in this level ecosystem. So we're a little pressed for time today, so I'm going to spend just a little bit of time on some ONI status, and then we'll get into some ONI certification and testing results, and go from there. So ONI supports a number of CPU architectures. I mean, the first ones we started off with the PowerPC with Freescale. It opened up a lot of the white boxes there. And then about this time last year, x86 started to become a big deal, and that took off like gangbusters. And then towards the end of last year, the ARM CPU architecture becoming more and more important for some of the lower end boxes. You know, people talk about having a out-of-band Internet Management Switch, or sometimes referred to as an IPMI switch. And in those cases, the ARM platform is important because it's low cost, low power, and tightly integrated. So we'll be adding support for that platform this year. It's about halfway done right now. This is just a slide to represent the really fantastic growth in the ONI community. I mean, we couldn't be where we are without all the support from all the hardware partners. As you can see up there, there's a lot of logos. It says 27 platforms over the past year. The source code for ONI is up there on the Open Compute GitHub. It's really pretty amazing to think about it. I mean, those 27 platforms, that covers all types of boxes. You have 1 gig boxes, there's 10 gig boxes, there's 40 gig boxes, and there's soon to be 100 gig boxes, as we saw from that talk. But yeah, that's really good growth there. Okay, anyone have any questions on ONI? I should have asked, how many people have ever heard of ONI? So that kind of get the idea, DHCP and image install environment and what have you. Okay, that's great. Okay, with that, we're going to move on to compliance and testing, and Carlos is going to fill us in on the details there. But I have to say, last year was the year that we really proved the idea. Many hardware vendors came on. We had to install environments. But now we really need to get things certified, really button things up now, so that customers and vendors can do things with confidence. We have reproducibility, and in some sense it's growing up a bit. So with that, we'll talk about compliance and testing.
Thank you. So since we launched ONI certification, we've had 3 releases so far. 2014-08, 2014-11, 2015-02. During the latest round of ONI compliance testing, we found a bug that no one has hit in 3 years. So we had to make an update. Thus, the 2015-02-01.
Let's hear it for testing.
Yeah. Right? So the prereqs, as some of you may or may not know, to do ONI certification is as follows. Is the ONI image available for download without a paywall? No one needs to register or whatever. They can just download it, get it going. Is the ONI source code or fork? Hopefully, not forking too much, and we're able to keep it in the main line available. Did you meet the requirements around labeling, like the luggage tag? Just simple things like that. A quick, a simple one-page quick start guide to make sure users are able to use ONI to get the NOS installed and running. Or if it came with a NOS already pre-installed and they don't like it, they have some instructions to how to uninstall it and put what they want on. Right? That's choice. Is that available? Is the hardware made available to the OCP testing labs to perform this? Okay. Last, and how can I actually do this at home before you submit the hardware, is you can actually run what we call OCE, the ONI compliance environment, to ensure that the automated build test suite is passing. This is the same suite these labs will perform in their own areas. Today, right now, 4 platforms from Acton has made it through ONI hardware certification. Okay. Many more are in the queue. Just a few minutes ago, I got an email that said alpha platforms have made it through ONI compliance testing. There are many more platforms in the queue right now. They have to meet those prereqs in order for them to pop out of the queue. But that's, we're growing. That's to be expected. This queue, I expect to just stay continuously populated. People will stay busy just with this. And the reason we do this, if it's not clear already, is we want to ensure platforms implement a consistent interface or an experience using ONI for the end users. This builds confidence in the product, and this builds our environment. One of the things we're going to be announcing, and you probably saw it last week on the mailing list, is we're going to be expanding the ONI certification, because right now typically it's just hardware validation to ensure that the hardware vendor implements ONI correctly, is we're going to start doing ONI NOS validation. Did the NOS comply with the ONI interface? Essentially, what does that mean? Well, does it recognize the install target, right? If you're in the NOS, you should be able to just install another NOS. If you're in the NOS, you should be able to be able to be uninstalled. There's no point if a NOS is installed using ONI and it cannot be uninstalled. That is no longer choice. Be able to go into the rescue and then the other modes as well, right? Probably the more important part is you don't tamper with ONI, right? You don't tamper with the partitioning scheme outside of the standard interface. And essentially what we're going to be doing is we're going to be implementing this with like a tripwire. Think of it like a tripwire type activity to ensure that you don't remove a certain set of utilities that other NOSes might depend on. All this is critical to ensuring a consistent interface for end users. And we have, right now, we're in the midst of brainstorming and putting together some ideas and test harnesses, and we are shooting for have this complete for the 2015-05 release. So, for those that don't habla, 2 months. So why are we beating this drum of testing so hard, right? You've probably been hearing us testing, certification. Well, this is talk 2, and expect 5 more talks to talk about this. Right? You see the luggage tag. You see the quick start guide. You see the now infamous funnel diagram. Right? Who wasn't here this morning? Okay, so now I get to reiterate this. All right. Don't worry, I'm not making fun of y'all. I just wanted to see if I can actually continue on. So essentially what we see is we see a funnel of the open compute technology incubation area, right? That's designated by this little funnel. This is where all our activities and all our work is happening, right? You see APD, you see SI, you see O&L, you see ONI, you see hardware. The output of that is an open reference, either the design or some software, and then combined with that is a test plan, the test spec. And then what's now OCP is able to do is perform validation that those components work as the spec is laid out. But that's not the entire battle, right? The rest of the battle is with integration of other components, like a NOS, like optics. And then the last piece is industry interoperability to ensure this works with everything else out there, to build user confidence. Okay? So again, ONI testing, it's really designed because it's all about the consumers, right? We want to make sure consumers have the best experience possible, because if they don't, they're just going to go somewhere else and get that. All right? We want to empower consumers through compliance, through automated compliance testing, right? We want to make sure everyone's on the same level playing field. No one has a leg up over each other, right? And we're going to do this with automation. So what we plan on doing in the coming weeks is with the OCP and maybe some, do we have any cloud people around? No cloud people. Okay. Now I was going to see if they can donate some cloud resources for this automated testing, but that's cool. It's cool. So essentially you have an automated build and testing facility. So essentially every pull request that is made on the ONI repo, a full regression test is made on all platforms running ONI. ONI, not ONI. ONI. Little Freudian slip there. And what that ensures is we didn't break anything. We didn't break any existing systems that are out there that are running, that are working. So in depth, we're just going to talk about what we did for ONI testing, right? So OCE, which we started in last December, is really composed of 3 different areas. One is this thing we call Build ONI. Build ONI, its entire idea was to simplify the building process of multiple ONI platforms. For example, if I want to build all of Alpha platforms, with all of Acton platforms, with all the rest, I think that's 16 more platforms in our GitHub repo, I should be able to do that with one command, as opposed to in different make entities. So we have that now, right? We focused on simplicity, and that's what we have. The next rev that we're going to be doing is we're going to be focusing on speeding up the builds. As you see, or as you've seen what Kurt printed out, in the last year, 27 new platforms came online, not including the 10 new ones that were announced just a few minutes ago. Right? The ONI community is growing at a faster pace than what we anticipated. So we need to make sure during the automated build and testing process, we build as fast as possible for the large array of platforms. All right? The next phase is a little utility called Test ONI. The whole point of Test ONI is to test ONI platforms to the ONI spec. Right now, Test ONI supports 70 out of the 80 test cases for ONI. 10 of those test cases require manual intervention, like unplugging the power, typing something on the console. And right now there is debate on should we automate these other 10 test cases. We'll leave it up to the user contribution. These 10 test cases are just being done manually, not only by the individual vendors, but also by the labs themselves. And this is the only part that is manual. Test-Oni actually uses real-world deployment tools. We did this on purpose. We want to use the same tools people use in their deployment schemes. We want to make sure that our config files for ISC, DHCPD, or DNS mask, or Nginx, or TFTP HBA, they all work. You can actually use Test-Oni to generate a given config file for any of these utilities for you to deploy in your real systems. Okay? And the last thing, like I mentioned, we're going to be doing NOS validation. Is a utility that hasn't been named, but we're kind of thinking test NOS. Yeah. It's essentially to test the NOS against the ONI spec. Right? And you see, discussion right now is underway on the mailing list. We expect to start implementing this probably by the end of the week, if not over the weekend while we're on a plane. And we plan to have it ready by the 2015-05 release. So let's talk about some ONI feature. Embedded ARM 32-bit. I think Kurt wants to talk.
Go ahead.
Does Matt want to talk?
No,
Okay.
I'm not armed.
So essentially what this is support for the ARM7 A CPU architecture, right? You've actually seen some of the industry already moving towards this. Basically, this is like for low-end or out-of-band switches. Basically, they're fanless-based switches. They're ARM-based. Right? Right now, we have QEMU support for quick prototyping. It's available right now in Kurt's architecture or one of his branches on GitHub. UEFI support. Right? UEFI is a standard. Everyone knows this, especially if you're in the hardware management track. All right. So if ONI requires a certain rev of that spec, that's a very specific term. Right? It's state-of-the-art for x86. Right? If you're running Windows 8, you got this running. So ONI and multiple NOSes. The purpose of this is we want to make sure ONI and multiple NOSes can actually interoperate a little bit better than what the current state is with Grow. And to also future-proof ourselves. Right? So UEFI is the only way to support the ARM64 platforms for those that are making switches back there. Right? And we have the initial prototype this on GitHub in Kurt's branch. And last but not least, ONI future, and that is APD aware. So we're going to be talking about APD coming up. This is a little precursor. Right. APD is the next evolutionary step for open networking. We'll talk about why and whatnot with here. What this means is, since essentially it's really just ACPI extensions, and those are going to be in Linux kernel, and ONI uses Linux, ONI can take advantage of these things. So what are some examples of APD-aware ONI? Well, ONI can be able to control all the, read all the sensors, control the fans, report the temp. Might be useful if you're running ONI 24/7 testing and you don't like the fans, at 100%, or if you want to prevent a meltdown. During the discovery phase, as part of the keys that ONI passes, ONI can say what ASIC is in the box. This could be important for those doing SAI, and they have a generic OS, and they're like, oh, it's a new box. I just booted it up, and it said, oh, look at this. This is XX chip here, XX rev here. Oh, okay, I can use this, and here's my operating system. Here's my relevant Ansible scripts, and out comes something else designed especially for that box. These are just some of our thoughts in our head. If you like where this is going, please chime in the mailing list. Right? Our imaginations are the limit of what we can do with an APD-aware ONI. With that, are there any questions? Let's get the other mic.
Actually, I have a few comments to make, too. definitely what's very, very cool is the amount of testing and hard work that went in by the certification lab at UTSA. I don't know if anyone from UTSA is here, but a huge thank you to those people because they put in a lot of time and effort and resources to help out with the ONI certification process. That was very nice.
First to comment, then a question. First, you guys are awesome. But there is more to that comment. You guys have big searches involved in this. I like to think that we are. You guys do all the work, so I just want to that. On the test NOS, is that something that would be useful for open network Linux, or is that even as lightweight as it is, it's too heavyweight for open networks? And apologies that I have been following the this discussion.
Well, I think that is one example where you want to see that tested there. Just like a lot of the ONI interoperability is tested today with ONI's little demo OS, Open Network Linux should behave similarly. You should be able to uninstall it and install it, and
certainly that doesn't.
The install process shouldn't kind of damage things. Those are the kinds of things we're looking for. Yeah.
Regarding the last slide that you mentioned about ECPD, is there a reason why it has to be only done from ONI and not from NOS?
Well, we're going to have an in-depth talk about what APD is, but ACPI are tables that are built into the BIOS. And so it's sort of independent of the operating system. ONI as an operating system can take advantage of those tables. The NOS that boots later as an OS can also take advantage of those tables.
There's no difference.
Right. And it's OS independent. It doesn't have to be Linux. That's the point. It comes with the hardware. It makes the hardware self-descriptive.
So if the hardware vendor is able to segregate the hardware specific part of the main CPU, for example, using the EMC, would that make the whole hardware compliant process much easier?
I'm not sure if EMCs make things easier.
That's just one example.
Right. I don't know. Is my answer.
Any other questions?
All right, that's good. Thank you.
All right, we're moving along here. Yeah, I think just we had you. You can go now. We had you after break. There were a couple of folks who also wanted to do. So by schedule, just to check with everybody, right? So we had a break at 2:15, so we were actually already ahead. It's awesome. There were a few folks who asked to maybe do a couple of quick 5-minute sort of lightning talk presentations. So just to give an update from the community. Are you okay going after break? Is that okay? That's fair enough. Is it a good? So I think we had a couple, and if you have a request, if you have something you want to, oops, sorry, if you have something you want to go over in terms of either contribution or working with the with one of the efforts, whether SAI or with ONI or anything like that, please let us know, and we can schedule and get you in on one of these sort of quick updates. But I think, Robert, did you want to update, give everyone an update from Alpha?
Thank you. It's kind of late. We have to be sleepy. So there's a group of old lady. They took the 5 beach. Ladies sitting behind that. And they were a few minutes into the trip. On the old lady back, that was shoulder of the fire. We know what's going on. In the head. peanuts. Then bunching it up, seconds. It's in the same lane that the black soda again. Also here, handful of peanuts. For the third time, the driver also didn't have his own lane. And this time he kind of was curious. What are you doing? You don't eat those peanuts? And the driver said, no, I don't have teeth. But I liked those chocolate around it. So I'll give you a real quick update. As you know, that Carol's already mentioned, we have two SKUs, 48 port, 10 gig, as well as 32 port, 40 gig configuration. We're glad to hear that our 48 port pass will be announced officially tomorrow. Plus, the 32 port, 40 gig is in process. And really, I want to take this moment to thank you for Junior, who they help Alpha to be involved in this historical making moment. Make man matter possible. Really, thank you, Judah. That's my update.
Yeah, so the files for the Acton, for the alpha switches are being reviewed by the IC, so that's a full design package, as Robert mentioned. Actually, I've gotten a couple of questions from other ODMs, from other vendors who are interested in contributing their hardware. On the wiki, there's a whole process for how you contribute hardware designs, right? And it starts with the specification. You submit a specification to the community, and then we review that within the community. That specification and the design package is given over to the incubation committee, who will then give their review and feedback as well. And then hopefully after, not too long, we're going to try to release, quicken, make this a little quick this year. We'll get it accepted to an officially accepted phase. Something we've also added, and I think Carlos mentioned it too, test plans are a huge part of this going forward now. And even for existing switches, we'd love to see more and more test plans so that we can get this whole certification and seal stuff right. Anybody else have any updates to share? Okay, come on.
Yes, we are going to make you stand up and get up in front of everyone.
Oh, by the way, so I've got all the presentations are online now, as well as the specs that I have to date. They're on the wiki. They're on the wiki. There's a link called Workshop, 2015-03-05, 03. So you'll see a Summit Workshop wiki page. I'll send it out to our list too, but all the slides as well as the specifications, like for example from Acton, are there right now.
I'm just going to give a quick update on where we are with SAI right now. SAI started off with version 2.90 in December, the proposal. Soon after that, we moved on to version 0.91. We have contributing companies, Microsoft, Dell, Broadcom, and Mellanox. Together we come up with 7 proposals. We now have a GitHub repository. You can see both the proposals as well as the source code there. And we will have our first demo based on this version 0.91 tomorrow. We have the 4:45 to 6 p.m. slot. We're very excited about that. We're gearing up on version 0.92. We have 15 plus proposals, and we're looking at a possible deployment. We would like to invite more contributions, and we want more participation as we move on to version 1.0. We see a lot of momentum, and we see a lot of contributors' feedback on the mailing list, but we would also like to see some pull requests as well. And we are going to cover over 20 plus proposals covering a broad range of ASIC architectures. So this is something that's also, I sent an email about this last Friday. This is just some details as to what the versions 0.92 covers. It has a few proposals like mirroring, S-flow, port numbering, lag, host interface. And we will also most likely have a cost, which is broken up into 6 different proposals now, and ACL and MPLS. We are looking at contributions specifically in tunneling, warm reboot, multi-process discussion, which will be led by Ben, and multi-NPU and extensibility. We're very excited about the SCI demo that's happening tomorrow. We are going to demonstrate it on a clause topology, which is a real use case, something that we use in our Microsoft data centers. What you will see specifically is you will see 2 different ASIC vendors, Broadcom and Mellanox. Sorry, that got edited out. You will see 2 different OS stacks working on these SCI implementations, which is Dell and Microsoft's. And you will see 2 different switching platforms, the Dell S6000 and the Mellanox's 1710. But most importantly, you will see 4 different SCI implementations, all compliant to version 0.91. They are from Broadcom, Mellanox, Dell, and from us. As we go forward, we would really like to welcome more and more participation. First of all, in features, there's a lot of interesting work going on right now, specifically in COS. There is a lot of work we need to start in tunneling and security. So anything you feel that you can contribute towards, please come forward and speak up. In addition to the actual feature implementations, we're actually looking at applications to see how we can actually make SCI more usable. Example of that is to have a SCI shell, to have some form of debugging, some sort of common logging. We're also looking at having some kind of a SCI simulator and a SCI testing. And this is very similar to what Carlos just spoke about, ONI testing, where you had the build ONI, the test ONI, the test NOS ONI. So we'll probably have to come up with something like build SCI, test NOS SCI. So we welcome any participation, and that's what I have. Thank you.
Any questions on the IRC?
Yeah, any questions here for SCI? Pretty exciting stuff there.
Thanks. Here's one.
Oh, here we are.
Possible. You said similar SCI implementation. When you say similar, should I be concerned about that word, or is this just the early stages?
No, you don't have to be concerned about it. They are pretty much the same implementations, the same API calls.
I'm assuming it's the same API, but it's different implementation underneath.
Yeah, so underneath they're calling different SDK implementations.
So one's built on top of,
About on top of the Broadcom SDK, on top of the Mellanox SDK, right?
Any other questions? So actually, thank you very much, Paula, for the update for the group.
Thanks for giving us the time.
So we've got some time until 2:30 where Rob is going to talk about Open Network Linux. We'd originally scheduled 15 minutes, but I think it's just we can just use this time just catch up with folks, talk about the different things. So we'll be back here at 2:30. Thank you.
Yes, it does.
Engineering, really on top. Yeah, it's a business. No.